Hello everyone. Today I am going to deliver a lecture on single phase inverter. This is a topic of subject Basic Electrical Engineering. Introduction to inverter. An inverter is a device which converts a DC input supply voltage into symmetric AC voltage of desired magnitude and frequency at the output side. It is also known as DC to AC converter. Here, this is the basic or general block diagram of inverter where we have an input in the form of DC and we get the output in the form of AC. If the input DC is a voltage source, the inverter is known as voltage source inverter, that is VSI. And if the input AC is a current source, the inverter is known as current source inverter, that is CSI. The output voltage waveform of an ideal inverter should be sinusoidal. The inverters are applied in adjustable AC speed drivers, uninterruptible power supplies, that is UPS, shunt active power filter, etc. This is a classification of inverters. The inverters are mainly classified into two categories. First one is voltage source inverter, that is VSI, and second one is current source inverter, that is CSI. The voltage source inverters are again sub-classified into two categories. First one is single phase inverter and second one is three phase inverter. The single phase inverters are again subdivided into two categories. First is fixed voltage and variable frequency inverter and second is variable voltage variable frequency inverter. The three phase inverters are again subdivided into two parts. First one is 180-degree phase inverter, second one is 120-degree phase inverter. The variable voltage and variable frequency inverters are PWM. The fixed voltage and variable frequency inverters are again subdivided into two categories. First one is half bridge inverter and second one is full bridge inverter. Depending upon the type of load, it may be a resistive load, a inductive load, a combination of RL and the combination of RLC. Now according to our syllabus, we will discuss about the single phase inverter. Single phase inverters are basic inverters which produce a square shaped AC output with a DC input. These inverters have simple on-off control logic and they are classified into two categories. First one is half bridge single phase voltage source inverter and second one is full bridge single phase voltage source inverter. Single phase half bridge inverter. For the half bridge inverter circuit, the center tap of the DC supply is used as one of the load terminals. The center tap is created by the two series connected equal valued capacitors across the DC supply. Here we have two transistors Q1 and Q2 and two diodes D1 and D2 and the load is a resistive load. The supply Vs is divided into two, Vs by 2 and Vs by 2. This is the operational circuit diagram for the single phase half bridge inverter where three arrows indicate the 3-wire DC source. It consists of two choppers. Now single phase half bridge inverters function in the two states. In the first state, when the transistor Q1 is on and transistor Q2 is off during the cycle 0 to T0 by 2. In this case, the transistor Q2 is off. That's why the path of conduction is shown by the red lines and the output voltage that will appears across the load R is plus Vs by 2. In the second case, when the transistor Q1 is off and the transistor Q2 is on. In this case, the path of conduction is shown by the blue lines and the output voltage that will appear at the load R is minus Vs by 2. This is a comparative study of both states. In the first state, when the transistor Q1 is on and transistor Q2 is off, the output voltage is Vs by 2. In the second case, or in second state, when the transistor Q1 is off and transistor Q2 is on, the output voltage is minus Vs by 2. This is the waveform with resistive load for single phase half bridge inverter. As we discussed earlier that during the time 0 to T by 2, the transistor Q1 is on and during the time and transistor Q2 is off. The output voltage across the load is plus Vs by 2. The middle waveform shows the value of instantaneous voltage when only transistor Q1 is on. The last waveform shows the value of instantaneous voltage when only transistor Q2 is on, and the topmost waveform is the final waveform. Here square waveform represent the voltage value and sinusoidal waveform represent the fundamental current. Now we will discuss about the second type of single phase inverter, that is single phase full bridge inverter. The single phase full bridge inverter consists of 4 choppers and 4 transistors Q1, Q2, Q3 and Q4. When transistors Q1 and Q2 are turned on simultaneously, the input voltage Vs appears across the load. If the transistors Q3 and Q4 are turned on at the same time, the voltage across the load is reversed, that is minus Vs. This is the operational circuit diagram for single phase full bridge inverter. Here the 4 transistors Q1, Q2, Q3 and Q4 are works as a switch S1, S2, S3 and S4 respectively. Here we have 4 diodes D1, D2, D3 and D4. In the case of single phase full bridge inverter, we have 2 conditions. In the first condition, when the transistors Q1 and Q2 are turned on and transistor Q3 and Q4 are turned off for the time period 0 to T by 2. In this case, switches S1 and S2 are closed and switches S3 and S4 are open. So the direction of current is shown by the red arrows and the output voltage that appears across the load will be plus Vs. This is the equivalent circuit of full bridge inverter when transistors Q1 and Q2 are on and transistor Q3 and Q4 are off during the time 0 to T by 2. Here we can easily see the switches S1 and S2 are closed and switches S3 and S4 are open. That's why we get the output VDC. Here VDC and Vs both are equal. So during the time 0 to T by 2 we get the output plus Vs or plus VDC. In the second case, when the transistor Q1 and Q2 are turned off and transistor Q3 and Q4 are turned on, in this case we get the conduction part as shown by blue lines and we get the output voltage across the load Vs as shown in figure, that is minus Vs or minus VDC. This is the equivalent circuit of full bridge inverter. Here we can easily see the switches S3 and S4 are closed and switches S1 and S2 are open. So the direction of current is like by this, and we get the output minus VDC for the time period T by 2 to T. This is the final waveform of full bridge inverter, where topmost waveform represents the output when the transistor Q1 or Q2 in conduction mode. In the second waveform, it is the output when the transistor Q3 and Q4 are in conduction mode. Third waveform represent the output voltage, and the last waveform represent the output current. Thank you everyone for watching my video.